Today we're working on 11.2 areas of trapezoids, rhombuses, and kites. Let's start with trapezoids. Height of a trapezoid is the perpendicular distance between its bases. If we look down here at our trapezoid, the line that's perpendicular is the line that is denoted h, which will represent our height. So this is similar to what we were doing at 11.1 with the perpendicular line being the height of our triangles. Area of a trapezoid is 1/2 the product of the height and the sum of the lengths of the bases. If we look down here at our formula then, so it's 1/2 times the quantity of our b1 plus little b2, all of that multiplied by h, which is our height. Let's do an example. The free throw lane on an international basketball court is shaped like a trapezoid. Find the area of the free throw lane. So we're given our formula here for the area of a trapezoid. And let's do our A equals 1/2, and our height is the perpendicular line between our bases. So that's going to be that, which is 5.8, multiplied by B1, which is 3.6, plus B2, which is 6. So let's add these together. We're going to get 9.6 multiplied by 5.8 multiplied by 1/2. And if we were to type this into our calculator, we would get 27.84 meters squared. And so that is the area of our trapezoid, which is the free throw lane of an international basketball court. Moving on with a couple theorems. 11.5, the area of a rhombus. The area of a rhombus is 1/2 the product of its lengths of its diagonals. Let's take a look at the formula. A equals 1/2 times little d1 and then little d2. So we can look down here in our figure and we can see that d1 is this entire distance here. If we're looking at this line, this is d2, the entire distance. And if we look at d1, this is this entire distance here. These make up the diagonals of our rhombus. 11.6 is the area of a kite. The area of a kite is 1/2 the product of the lengths of its diagonals. We can see here that A equals 1/2 d1 times d2. And it's once again important to realize that d1 is this entire distance here, and d2 is represented by the entire length here. Let's move on to our first example. Rhombus PQRS represents one of the inlays on a guitar. Find the area of the inlay. We need to recognize that we're given a rhombus, and we can tell it's a rhombus because all 4 of the side lengths are congruent, and that is represented by the single lines. If we need to find the area of a rhombus, if you recall, the entire area is equal to 1/2 diagonal 1 times diagonal 2. This is important to recognize that when we say diagonal 1 and diagonal 2, we mean that the entire length of the diagonal, which goes from P all the way to R. We're only given Pn. In order to find our entire length, we need to do PR. In order to find the entire length of PR, we need to do PR is equal to Pn plus Nr, which will be 12 plus 12, which is equal to 24. Since we found diagonal 1, we need to now find diagonal 2, which will be this entire length QS. If we are finding the entire diagonal length of QS, that is also going to be QS is equal to QN plus NS. And we know that QN is equal to 9. And because we're dealing with a rhombus, NS is also equal to 9, which will give us a total length of 18. Since we now have the entire length of our diagonal 1 and our diagonal 2, we can come over here to the area formula and simply plug them in, which will give us a total area of 216 millimeters squared. Moving on to example 3. One diagonal of a kite is 2 times as long as the other diagonal. The area of the kite is 56.25 square inches. What are the lengths of the diagonals? This is a multi-step problem, so let's break it down. It says that one diagonal of a kite is 2 times as long as the other diagonal. To represent this, I will use this line as 2x, and I will use this line as x. The formula for the area of a kite is A equals 1/2 diagonal 1 times diagonal 2. We have our diagonals here, which are represented by these two lines, 2x and x. Now let's plug them in and let's solve for x. We are given our area, and it says that the area of the kite is 56.25 square inches. So our area is 56.25, and we carry down the 1/2, and we will represent diagonal 1 as 2x, and we will say that diagonal 2 is x. I'm going to distribute the 1/2 through, and we can get rid of our 2 in front of our x, so we're left with x times x, which will give us x squared. Square root both sides. That means x will equal 7.5. So we know that our x is equal to 7.5. And to find our 2x, all we need to do is multiply 7.5 times 2, which will give us 15. What I forgot attached to each number would be the label. So the label on both of these would be inches. Let's work on finding the area of this figure. It's important to realize that this figure is a trapezoid. This was the first theorem that we worked through. The area of a trapezoid is equal to 1/2 the height multiplied by the quantity of the base plus the other base. So B1 plus B2. Let's label some of our parts here. We'll say that 6 is B1. We will say that 8 is B2. And the height is going to be the line that is perpendicular to both bases. And what we're given here is 4. As you can see, this is perpendicular to both of our bases. So 4 will be our height. Carry down our 1/2, and we multiply this all out. We will get 28 feet squared. Working on another example, this time, as you can see, we are not dealing with a rhombus, rather we are dealing with a kite. But the area formula for a kite is the same as a rhombus. The area will equal 1/2 D1 times D2. And we are given the full length of both of our diameters, so we can simply plug those in. We will say 1/2. We will use 6 for our diagonal 1, and we will use 14 for our diagonal 2. And when we multiply this all out, we should get 42 inches squared. For our final example, we'll find the area of the figure. It's important to identify what figure we are dealing with. You can see 4 congruent sides, which means we are dealing with a rhombus. So let's first put down the area formula for our rhombus. The area formula for a rhombus is area equals 1/2 times diameter 1 multiplied by diameter 2. And are we given our full diameter lengths this time? No, we are not. If we remember back to a previous example, all we will need to do are multiply by 2 or add the partial lengths together. In this case, we will do this line as diagonal 1. So to find diagonal 1, we could do 30 times 2, which will give us 60, or we could do 30 plus 30, which would also give us 60. And to find diameter 2, we would simply do the same thing. So we could do diameter 2 is 40 times 2, which will give us a total length of 80. Now, since we have our entire diameter length, we can plug these into our formula. We will have 1/2 diameter 1, which is 60, multiplied by diameter 2, which is 80. And if we multiply this all out, we should get 2,400 meters squared. And just as a simple caution, when you're working through these problems, it's always important to identify if you have half of the segment or if you have the entire segment. And this will conclude video for 11.2.